Welcome to part 2 of the service video for this 1966 Custom Kraft Power Sonic amplifier. We join our troubleshooting already in progress. Well, I don't know yet if this is actually causing the problem that I'm experiencing here with the tremolo not working, but this socket, this V2 socket, definitely needs to be replaced. It's getting intermittent connections. I tried to tension it by pushing the contacts together on the other side with a small implement, and that just wasn't working out. I put the tube back in, and it's just, I mean, it doesn't even get fire in it until you wiggle it around, and finally it will get some fire, but then other contacts aren't contacting. So I need to replace this socket, and then we'll come back to the troubleshooting. Alright, our new ceramic socket is not going to fit inside the hole properly, so we're going to have to widen out this hole. Alright, we have our new socket wired in, and probably nothing I hate more really than putting new sockets in a tube amp. That's one of the worst things I like doing about this sort of work. But anyway, there is the new socket, and let's stick some tubes back in it and see what it does now. Alright, I have this thing plugged back in and on, and it's working, but it's a hell of a lot quieter than it should be for some reason now. And we're getting some noise on the first socket at this point. The second socket seems fine now. But and I've changed preamp tubes as well, just in an effort to try to track this problem down. But the first tube socket, well, it's not so bad now, but it was giving me some problems. At any rate, it's way quieter than it was earlier. Earlier, I was getting a lot more volume out of this thing, and I don't understand quite what's going on at the moment. So I'm doing some more experimentation here to try to figure out what the hell's gone wrong between putting that socket in and now. I'm probably just going to go through here, I guess, and check each and every one. I've already checked all the voltages, all the plate voltages, and on all the tubes are fine. All the tubes are glowing. So we have fire in all of those, like we should. But something just is not right. So we're going to have to go through here, probably resistor by resistor, and measure each and every single one and figure out what the hell's going on. Okay, I've now rewired both of the preamp sockets. I've put new ceramic ones in both the V1 and V2 positions, and hopefully that solves the problem that we were having with both of those being intermittent, because they were frankly just really crappy sockets. So yeah, let's get some tubes back in this thing and see if that helps. I'm kind of skeptical that it's going to, but I'll put some brand new tubes in here if I need to, and you know, try to narrow things down. But you know, I'm kind of running out of options at the moment. I may have to bust out a signal tracing technique here and just go through step by step. But that's kind of what I'm left with. I've checked all these resistors, and they all are fine. At least you know, cold on the desk. I haven't really checked. You know, obviously I really haven't checked them up to voltage, but all the resistors and everything seem fine. So I'm kind of at a loss, unless it's just a tube issue that I'm not catching, or whether it was one of those sockets. So let's see what it does when we fire it back up. Okay, here's what I've done to troubleshoot this thing. I've got a guitar here with the cable. The cable is actually being, the ground is going to ground, obviously. The red wire here is going to directly to V1, to the grid of V1. So it's bypassing all of these resistors and everything up front. So it's just going directly into the tube. Coming out of the tube, it goes through, it comes out of the plate, obviously, goes through the coupling cap, and eventually goes into the grid of the next stage. Off of that stage, I'm coming off with this yellow wire here, and the yellow wire is going over here to another cable that's going to my little practice amp back there that I use for bench testing. So essentially what we've got is the first V1 stage is what we're testing. Everything from the input of the first tube to the input of the next tube. We're testing everything between those 2 points. And right now, it's working fine. I can actually unplug this where the guitar is going to V1, and I can take this, and actually I might as well go ahead and demonstrate that so that you can see. But I can flip that amplifier off for the moment so I don't get a lot of noise. But if I unplug these and just plug directly here, okay, so now we're plugged directly into the amp. I'm going to turn this amp over here back on. Alright. I do get something, but it's if I unplug this, let's see. So that's actually working as well with my guitar plugged directly into the input. I'm basically testing everything up front. So I'm testing everything from the input to the grid of V2. So everything from the input up to the grid of V2 is fine. It's actually working as it should because I can get my volume and my tone knobs are actually in that loop, and they do work. So both of those work. So I've eliminated some possibilities. The tone knob's fine, volume knob is fine, the input jack seems to be fine. Although earlier it seemed to be a bit intermittent, but I don't know. This has just been one of those really weird ones. So that's telling me also that my input resistor here should be fine. Everything associated with V1, such as the cathode resistor and bypass cap, which is brand new, are all fine. All the wiring for this socket is fine. Coupling cap should be fine, although it probably wouldn't hurt to just tap on a couple things there just to make sure they're not intermittent. Yeah, I think everything basically on the V1 stage is A-OK. Okay, so with the amp all the way down, we're just going to move our jumper wire from here, okay, over to, and we want to make sure we get this right. We want to move it to the input of the phase inverter, which should be right there. Well, that's certainly weird, because when I did that, when did that, it gave me a little pop on the speaker here. Okay, so this is one of those moments where you feel really, really stupid. I came in here earlier, you know, obviously I had to rewire these sockets, and when I was replacing this socket, I had to replace this piece of wire right here, so I had to desolder that. And when I did, I think what I've done here, do you see my problem? Here is this red wire right here. Well, let's see if we can get you. This red wire right here is our power coming in. Okay, so this is our DC power coming to here. There's a jumper wire running to here. This powers the plates. This one going to this plate on this side, and the other one going to the other plate on the other side. So these are our plate resistors right here. You'll notice here is the cap where you would expect to see it on this side of the plate resistor, but where is this cap? And actually I tacked this in just now because I was sitting here thinking, well, maybe this cap right here is bad. But look at where the cap is going. What side of the resistor, the plate resistor, is my cap on? The complete wrong side of the plate resistor. So really stupid miswiring on my part. This should be right here, and I think that's going to solve all of our problems, at least with the amplifier itself. Now our tremolo, that's another story. We may have to come back and rewire some stuff to get that correct, but for now at least this needs to go obviously over there. So dumb, stupid me. I've been sitting here chasing this thing around like, what the hell's the problem? That's the problem. Alright, we moved that lead over to where it's supposed to be, and here's the moment of truth. Let's fire up the amp and see what happens. I mean, you and I both pretty much already know what's going to happen. As soon as I hit a chord, it's going to work precisely like it's supposed to. Because it's a tube amp, and it's not that big of a damn mystery, and I don't know why I did that, except maybe just lack of sleep. That's what happens when you have a newborn baby. You don't get any sleep, and you do stupid things like that. But anyway, yeah, the amp is pretty killer now. It's going to sound great. It's a good thing, actually, that I changed both of those sockets, because now they're extremely tight. There's no noise whatsoever associated with the sockets, because before you could even just breathe on those tubes, and they were just, I mean, those sockets were gone. So yeah, that's a good thing. The only thing left to do now is to service this tremolo, and we'll see what we need to do to get that going. Okay, tremolo is one of those effects that there's about 100 different ways to do it. But essentially what you have is you have a tube that is oscillating, and the oscillation produces a change in some other part of the circuit. Usually that part of the circuit has to do with one of the tubes biasing in some way. Like for instance, this is a Gibson GA19 RVT. You've probably seen a few of my videos featuring these amps. This tremolo circuit works. Here's your oscillator tube, and it oscillates. No huge mystery there, but it works by varying, in this case, the grid leak resistance on the output tubes, it looks like. This is a cathode biased set of output tubes, but they do have grid leak resistors, and this resistance gets varied depending on the oscillation of this tube. So that's how this one works. Now this is altogether something different. I've traced this out, and rather than draw a schematic of this, I just thought I would kind of show you what it's doing. Okay, here's what we're dealing with on this tremolo. I can't get the thing to actually send the actual signal into oscillation. The tube is clearly oscillating, and I can get it to start working at certain times when I put the turn the depth all the way up, and when I have actually the signal jumpered across this this diode right here. But this diode, it seems to be the problem. I don't know if this is original or what's up with this design, but I'm gonna actually do something a little more conventional and try to modify it so that the oscillation gets injected here into the signal. So it'll actually be changing the bias slightly on the output tubes here at this point. So that's kind of the plan at the moment, and this is again from a GA19 RVT schematic. But this is just a bit more of a conventional way of doing it than what they were trying to do here. Which, without drawing out a schematic, I know it's kind of silly for me to even talk about it without drawing out a schematic. But basically, what they've done is they've tried to inject the depth control through a diode, and the diode is getting hooked in here on the treble pot, the tone pot, but that same connection actually ends up going to V2's grid. So essentially they have it hooked directly to the grid of V2, that diode. So they're trying to basically inject the oscillation right there at that point, at that grid. So it's not very effective the way that it's working now. I mean, it's not working at all. So we're going to try to do it a little more conventional way and inject the oscillation into this point. There are 220K resistors, just like in this design. The output's actually kind of similar in this amplifier, so that's why I'm sort of looking at this. But we're going to inject it here. In the design, they actually have this going directly to ground from this point. It's just grounded. So instead of just being grounded, we're going to run it through our depth control first to ground. And in order to do that, we're going to have to remove this little jumper wire underneath this board. So we're just going to clip this temporarily and kind of move it to the side. That way, if it doesn't work out and we end up undoing this, we can just solder it back together or just replace the wire or whatever. But I'm just going to clip this out and add in a wire going from here, which is the center of those two 220Ks. We're going to come from right there right to, we're going to eliminate this diode as well and just go right to the depth control like we see sort of on this schematic, and hopefully that gets our signal to oscillate. Alright, so we've raised the leg of that jumper wire so that that's no longer grounded at the center of those two resistors, and we've added a gator clip to our depth control, which is going to ground through this other resistor right here, and we will see if that fixes our tremolo problem. So let's check it out. Okay, in addition to injecting our signal here, we're going to use a 0.22 capacitor, and instead of coming off of the cathode as is shown, or as is actually in the amp, we're going to come off of the plate instead. So we have a setup here. We're going to the middle of those two resistors, those 220Ks with our alligator. So there's where one end of our alligator clip comes off, going through this guy, and we'll see if we can get the signal to oscillate. See if you can hear that. So there, it's actually working. And we can control it with the rate. So that's going to the plate of our oscillator tube. We can actually control it with the rate. Let's slow it. Let's slow it way down, or speed it up, I guess. See how fast we can get it going. And we'll just go to the tube here. Whoops. Actually, we'll go here. You can see it's sped up considerably. So that's actually working now, but we just need to get our control in line with this capacitor, so we need to come off the plate, through the cap, and then go to our depth control. So we need to rewire our depth control so that it is in a different position. Here's a quick tip. If you're having to install a cap or some other component across a board where it's going across many things, and you want to insulate the leg of the component, rather than busting out your shrink tubing all the time, you can just get a piece of wire like this.
Just make sure it's the appropriate gauge, and then you take your wire stripper and just strip some of the insulation off of another piece of wire, and that leaves you with a piece of insulation that you can then put on your component's leg, so you don't have to keep using up all of your shrink tubing.
And there's what the insulation will look like whenever you're done, and you can go across multiple components without fear that it's going to short out against something else. I'm convinced at this point that the big 0.5 microfarad cap that we had coming off of the cathode and going to this same point and then on to the depth control was in the wrong position to begin with. I think it was either in that position from the factory wrong, and they just never did quality control and testing on it. It may be that this thing never worked properly. And it could also be that it's a case of someone having come in here and changed a few capacitors and mixed some things up, much like I had mixed something up over here. Of course, I was diligent enough to catch it, but maybe they were not, and they just said, "Why isn't the tremolo working?" But it was in the wrong spot, I believe, for the tremolo to even work. I'm not sure how this thing would have ever worked with the tremolo set up the way that they had it. At any rate, we're going to set it up in a way that it will work, and here's what we've done so far. We've added a 25 microfarad bypass cap to the oscillator, just like we saw in the Gibson schematic. We have moved this capacitor from the cathode, where it didn't belong, over to the plate, so now we have it coming off the plate like it should be, and we are set to put in our depth control now. And before we actually hardwire everything, I have the control out here, and we're just gator clipping it in where it's supposed to be. This wire is running through our 22 microfarad or 0.22 microfarad capacitor from the plates of the oscillator tube, and we're just making sure everything's clear and nothing's going to short, and then we're going to fire this thing up. So let's turn on the variac. Let's also, since we've been shuffling this around, let's make sure our output is not shorted. So yeah, that's good. And these are just the little checks you want to do before you actually fire the thing up. So let's give it power. Let's see what happens. Alright, we have volume, obviously. Well, it does work, but it doesn't work very well. The control, I think, is actually too much. We also have a resistor on there that I don't think we need, so we're going to get rid of that resistor and just jumper that across. In fact, we can probably go ahead and do that. So let's turn down the volume for a second and just get another jumper gator clip wire. So we'll just come off the ground, and actually that's supposed to go to ground anyway, so we need to go to the chassis ground. And actually, let's test it like that before we do anything else, because that's one thing I did forget to do. Okay, see there? It just seems to kind of come on and off all at once. It does work. You can hear it oscillating. But it's not working very well. See there? So, let's see if we can improve the sweep of this. Let's turn that back down. Maybe we can get this to, let's see, we'll come off the leg right there. Maybe that will eliminate that resistor. Yeah, see, that's kind of an unacceptable. It is working, but it's a bit unacceptable in the way that it is. At least it's working. We're going to change this pot. I think this pot might be a 1 meg pot. The design that I'm kind of copying this from is a calls for a 250K. So let's go to a smaller pot. Okay, our old pot is just kind of hanging in the breeze. It's attached to nothing right now, and we've got this 250K pot attached out here to where it needs to go. Let's turn it up just a little bit so we can hear the noise. And you see how that smoothly faded into oscillation there? That's what you want to hear. Okay, we have this thing totally completed now. Everything is sounding absolutely great. We haven't quite picked a speaker yet, so we're going to get everything back in the cabinet, pick a speaker for the customer. At his request, we did add an output jack here, so he can unplug it and plug in whatever speaker cab he wants later. This amp also had no fuse, so we've added an inline fuse holder. 3-prong cord, of course. We left the original can capacitors because they all tested absolutely fine. No problems with any of those, which is weird because we had problems with half of the rest of the amp, but no problem with those. But yeah, got that new pot in there for the tremolo depth. Rewired the tremolo pretty much entirely. Replaced all of the coupling caps and signal caps. We added a 25 microfarad bypass cap on the tremolo oscillator, and also replaced the bypass cap for the V1 stage. But yeah, everything is cleaned, serviced fully, and completely ready to go. So let's give this thing a short listen here. And I think you guys will agree this is going to be a killer sound. Alright, we're finally ready to test out this Custom Kraft amplifier. I've installed a 1959 Rolla speaker. It's an Alnico in here. And it came out of a Hammond organ. And we're going to use a 1967 Gretsch Chet Atkins Nashville just to test it out for the hell of it, because why not? Right now the volume's on about a quarter of the way or so, and the tone is about a little over halfway.
crank it up just a little bit higher. Put about halfway up. Check out the tremolo. It gets pretty deep, but I have noticed if you go all the way up with it, it does kind of chop out a little bit. See there? Let's see how much it will break up. We're, like I said, we're over halfway up right there, but let's see what we can do with it as far as break up. So yeah, that is the 1966 Custom Kraft Power Sonic dual 6L6 or 6V6 rather amplifier. Hope you've enjoyed this video. If you guys haven't already done so, please click subscribe below to subscribe for future videos just like this. And for now, y'all take care.